We are now starting with the second lecture of trigonometric sketches. Remember what we have done in the first part, because that basics will be applied over here again and again. In the first lecture, we discussed how a sin x graph is drawn, what is the period of a sin x graph, what are the four transformations associated with a trigonometric graph, and what happens if the domain, the range of values of x is changed, what happens to the shape of the graph. Now, in this lecture, we would be focusing on the graph of y is equals to cosine x. In short, it's known as cos x. Y is equals to tangent x. In short, it's known as tan x. And what happens when the four transformations are combined for a single trig function. It's not necessary that all four transformations are combined at the same instant. It could be two of them combining, it could be three of them, it could be all four of them. Now let's start with the graph of y is equals to cos x. It is very, very similar to the graph of sin x, except this looks like sin x. But look at the graph. It's not starting from the origin. It's not starting from where the y-axis and the x-axis meet. That is basically the origin. It is starting a little bit back. It is starting from minus 90 and it's going all the way till 450. That means it's just like a graph of sin x, except if you want to start from a particular point, instead of origin, it's starting from minus 90. Now, we are usually interested in the section of a graph, in the snapshot of a graph that is between 0 and 360. So after labeling the major points, let me draw another shape. This is what you have to remember. At 0, cosine of 0 is 1, 90, cosine is 0, 270, cosine is 0, 360, it's again 1, and 180, it is minus 1. Now, what were the four transformations? The four transformations were, the first one was the graph of minus cos x. The purple graph is the original one. What will happen when a minus sign is applied? It is reflection in the x-axis. That's how you label the point. Drawing dotted is usually easier compared to a solid line. And the blue one is the graph of y is equals to minus cos x. Let's move on. Now, y is equals to 2 cos x. This is the original one. Label the maximum as 2 and minimum as minus 2. After practice, there is no more need of drawing the original graph. Y is equals to 1/4 cosine x. The same as the previous graph, except the maxima is labeled as 1/4, minima is labeled as minus 1/4. These two graphs are of the category y is equals to k sin x, where k is the coefficient of the trig function. It could be k sin x, it could be k cosine x. Y is equals to cos x plus a constant. Which one is it? Recall, this is the one in which the graph is translated either vertically up or vertically down. If the constant is positive, it moves up. If the constant is negative, it moves down. The blue one is the final graph. Set of parallel graphs, distance between them remains the same. The blue graph is shifted vertically up. The blue graph is the final one. The red one is shifted vertically up and becomes the blue graph. Y is equals to cos kx. What was the rule? K cycles in 360 degrees. The rule for cosine and the rule for sine is the same. K cycles in 360. Y is equals to cos 2x. 2 cycles in 360. And remember the slogan, first draw, then label. One cycle, second cycle, 2 cycle in 360, therefore 1 cycle in 180. Which is this one. After looking at the graph, you can predict the equation provided it finishes at 360. Yes, it finishes at 360, 3 cycles, therefore the equation is y is equals to cos 3x. Y is equals to cos half x, half a cycle in 360. Okay. Now, after looking at all these transformations, the second graph is that of tangent x. Y is equals to tangent x. Now, before we start with tangent, there is something I would like to focus on. If I calculate the tangent of 89 degrees, it comes out to be a large value. That is 57 point something. If I move on to 89.5, the value doubles. Amazing. Strange. Just a difference of 0.5 in the degree value increases the ratio value by double. Tangent of 89.9, that is 10 times the value of tangent 89 approximately. Tangent of 89.99, that is increased even further. 0.1 increase, in addition of 0.1 is taking the value and multiplying it by 10. Tangent of 89.999, what do you think would happen? 57295. That means it increases very, very, very sharply. That means tangent of 90, the calculator tells you it's a math error because the calculator is unable to comprehend what it means. Tangent of 90 is so big that the calculator does not have space, even with significant figures, even with the scientific notation, to take care of it. It's almost undefined. It is undefined. It is infinity. That's how one cycle of tangent is drawn. Why am I making this line dotted? Such a line is called an asymptote, a line which a graph can approach but can never actually touch it. These graphs are seen in tangent. They are seen in exponential functions. They are also visible in the graph of logs. So now, minus 90 to 90 is one particular cycle for a tangent. Again, our usual standard is drawing from 0 till 360. Now this time, one cycle is taking 180 degrees to complete its path. So therefore, the purple one is the graph of tangent x, that's one cycle. The green one is the other graph. That means there are two cycles in 360. That means something has changed. Y is equals to cos x, one cycle in 360. Y is equals to sin x, one cycle in 360. But y is equals to tangent x, two cycles in 360. That means the period is 180 degrees. And also this rule has to change. Y is equals to tangent kx. That means 2k cycles in 360 degrees. Y is equals to tangent x. What's the coefficient of x? 1. Therefore 2 times 1 is 2. 2 cycles in 360. Also we should remember that tangent of 45 is 1. Tangent of 135 is minus 1. These are two nice reference points that should be plugged in the graph. The reason being, contrary to the graph of sine and cosine, the maximum was 1 and the minimum was minus 1, and you can play around with that. In tangent, the maximum is infinity and negative infinity. So as such, you need a reference point somewhere in the middle, and 45 degrees is a beautiful number. It lies exactly halfway between 0 and 90. And the value of 45, tangent 45, is 1. So it's very nice to label it. And this concept would be used later on. The same as the scenario with 135 degrees. Tangent of 135 is minus 1. Now, applying the transformations, and this time first with the transformation of tangent kx. A little math is required. Y is equals to tangent 2x. Value of k is 2. That means there should be 4 cycles in 360 degrees. Now I'm drawing a cycle in blue, another cycle in red or rust, third cycle in purple, and fourth cycle in green. 4 cycles in 360, label 360 at the very end, and cut the x-axis according to your needs in the proportional way. I think it's pretty obvious. As long as you stick to the rule, first draw, then label, from my experience, I can comfortably tell you that people make the minimum amount of mistakes. If someone tries to diverge from this particular rule, If someone tries to innovate new rules, then things go a little bit shaky. People tend to get things wrong. Do things the easy way. Y is equals to tangent half x. The value of k is half. Double of half is 1. That means 1 cycle in 360 degrees. The scale is in your hand. No need to stretch the graph. Just draw a simple one. It's the labeling that matters. 1 cycle in 360 degrees. Now, y is equals to minus tangent x. Pretty straightforward. Draw the graph, draw the asymptotes, reflect in the x-axis. I have drawn one single cycle till 180. If the examiner have asked me to draw till 360, I would simply copy-paste this graph and the same pattern would be repeated. Y is equals to 2 tan x. Can you multiply infinity by 2? Can you multiply negative infinity by 2? No. What you will do? You would use the value tangent 45 is 1. So now, when I plug in tangent 45 in this equation, the value of y comes out to be 2. So therefore, label 45 degrees and label a 2 over there, and label 135 degrees and label a minus 2 over there. Deliberately, I have not done this. Let me retrack a bit back. This graph, the original one, 2 tan x would be the same. Instead of 1, simply write a 2. Instead of minus 1, simply write a minus 2. If it's 1/3 tangent x, 1 would be replaced with 1/3. And minus 1 would be replaced with minus 1/3. Now, let's move on. Y is equals to tangent x plus 1. The graph will move vertically up by 1 unit. Combo of transformations. Now, in this one, we would be focusing on minus k sine x plus minus a constant and combination of transformation with the last one, which is y is equals to sine kx, cos kx, and tangent kx. Now, we have studied each one individually, each of the transformation individually. What happens if you get an equation like this? Focus on the equation. Always start with the trig function. You should be drawing the graph of sine x. You should be doubling it. And you should be adding 1 to it. In this case, do I need to really draw the graph of sine x? Or I can simply draw 2 tan x, label the y-axis properly, as accurately as possible, and shift the graph up by 1 unit. I think I would choose this method. I would try to minimize my steps. And that's how the graph is drawn. Y is equals to 1 minus sine half x. Basically, it's minus sine half x plus 1. Draw the graph of sine half x. Reflect it in the x-axis. Once the reflection is done, translate it up by 1 unit. Y is equals to 3 tangent x plus 1. Wait a second, let's see. This blue line, this blue bar, should I label it 1 and then label it 3? Or should I just directly label it 3? I think the second option is better. This is 3, this is minus 3, this corresponds to 45 and 135. Plus 1. Shift the graph up by 1 unit, and that's how the graph is drawn. Y is equals to 1 minus 2 tangent half x. X lies between 0 and 180. Now think for a second. Tangent half x. Tangent half x 1 cycle in 360, but the examiner is asking me to draw till 180. So therefore I should draw half a cycle. And there is also the flipping involved. There is also the 2 involved. So let me draw a rough one first. This is half a cycle. And what have I drawn? I have drawn y is equals to 2 tangent x. 2 tangent half x. Now if I flip it, it would go down. That's the blue one at the left. And now I'm drawing the final one. minus 2 tan half x, the blue one on the left. That will be shifted 1 unit up. Now in this graph, if this was a graph of functions, if this was asked with reference from function, domain, range, and all these things, the examiner would have asked you, what is the range of this function? Range simply means the difference between the highest and the lowest value. That's the statistics perspective. Range is writing a function between two values. The y values would lie between this and this. The highest y value in the final graph is 1. And what is the lowest y value? The lowest y value is infinity. Therefore, you would simply write f(x) is less than or equal to 1. We will focus more on such graphs when we would have studied functions. So now in the second lecture, what have we studied as such? Cosine, tangent, combination of transformation in full detail. So now the basics of sketches are done. In the third upcoming lecture, I would be focusing on some exam questions and explaining them in full detail. Take care.